We know in physics we use some mathematical concepts, and one of the most essential concepts in mathematics useful in physics is differentiation. So today let us focus on this one. Let us learn some basic equations required for us. Let us begin. Welcome to Physics A to Z. What is differentiation actually? Let us see. Let us assume there is a variable y. There is another variable x. The value of y is depending on x. So we write y is a function of x, meaning the value of y depends on x. So we write it as function of x. If x changes, the value of y obviously will change. Now, what is meant by this differentiation? I differentiate y with respect to x. With respect to x. What does it mean? We will write this one as dy by dx. What is it actually? Dy by dx here is called differential operator. Okay, what is it called? Differential operator. And by writing like this, what do we mean is we are finding change in y. Okay, change in the value of y with respect to change in value of x. When change in x is 1, delta x indicates change in x, delta y indicates change in y. So we are finding delta y with respect to delta x. If x changes by 1, what will be change in y? Just we are finding this. So delta y by delta x only. But here the changes are very, very small. In such case, we are using this notation, right? That differentiation. All right. So why is it useful to us? Let us see. So first of all, dy by dx is nothing but, remember this, differentiating y with respect to x. That is nothing but same delta y by delta x when the delta x value is very small. All right. So now let us see how to use this one. Let us say we drew a graph between x and y, and assume that the graph comes something like this. So if I want the slope of the graph, what do we do? Slope of the graph, we take 2 points, let us say A and B, like this. Then this is the graph between them. I will draw x-axis, a parallel line to x-axis, and I find the angle between the x-axis and the graph. Let us say it is theta. Then slope of the graph, where between A and B. Between A and B, slope of the graph is tan theta. I can also write by using coordinates. Let us say x coordinates of A and B are x1 and x2. Similarly, y coordinates, let us take y1 and y2. Now the slope can also be written as y2 minus y1 by x2 minus x1, like this. So this is also slope. This is between 2 points. If I want at a single point, let us say the graph is a curved line, something like this, and I want the slope at this point. Say let's try to find the slope at this point. Let's say A. I draw a tangent at point A first of all. Then I find angle made by this one with x-axis. So if I draw parallel line for x-axis, this is the angle made. So this angle, let us say theta, is the angle between x-axis and the graph. So slope is equal to, at point A, it is tan theta, where at point A. Similarly, if I take a different point, then I draw a different tangent there. There the angle can be different, slope can be different, right? The same thing, finding slope at a point without using the angle, using an equation. To find this type of quantities, we use differentiation dy by dx. So simply, what is dy by dx? It is nothing but slope of the graph yx, right? Where at any point. So we can find slope of the graph by using differentiation. So this is basic concept of differentiation. Where do we use this one? For example, in kinematics, you know, velocity is found as change in position by change in time interval, which is x2 minus x1 by final time minus initial time. This is average velocity. How do you find instantaneous velocity? Velocity at a given point. Suppose you are going from point A town A to a town B. Average velocity you can simply get finding the total distance and total time taken. You got the average velocity. You get average speed also like that. But how do you find instantaneous speed at any given point? Suppose you are crossing an electric pole. At that electric pole, what is your speed exactly? You should know without seeing the speedometer. For this, the graph between displacement and time helps to find out instantaneous velocity. Similarly, instantaneous speed also by using distance and time graph. So now that kind of operations are done by using differentiation. So what are we doing actually? We are breaking the journey, our journey, into small parts, very small parts. Each one is nearly 0. And we take this part of the graph, this part of the journey. And by using that part of the journey, you can find out the velocity or speed at that particular point. Right? This is basically differentiation. Okay, so how do we use this one? And remember one thing, we are not learning entire differentiation here. We are learning some equations which we need in physics, not the entire differentiation. Differentiation is a very large topic you will learn in mathematics. Now we are seeing a small part of it, some equations which we need. Okay, so do not overthink why it is like this, why it is not like that. Leave all that. Just learn some equations and practice how to use them. That is enough for physics. The history, the reasoning and all, everything about differentiation you will be learning in math. Okay, come to the point. So now let us learn some equations we need for differentiation. As we assumed, y is a function of x, right? Next, how do you indicate this differentiation? Let us see. Dy by dx, which is differentiating y with respect to x. What is y here? Y is a function of x, right? This can be written as simply y dash, or you can write it as f dash of x. You can also indicate this one as y with a dot on the head. These are various methods to indicate differentiation. You can also write like this: d by dx of f of x, or d by dx of y. All these things indicate the same method, which is dy by dx, differentiating y with respect to x. Okay, now let us see some important equations to remember to do differentiation. Okay, The first equation to remember, d by dx of a constant is 0. Because it is a constant, it will never change. So differentiation of a constant is always 0. Second one, d by dx of x power n. X power n, this is the mostly used equation in differentiation. So d by dx of x power n, this is n into x power n minus 1, nx power n minus 1. Let us take an example, d by dx of, let us say, x cube. What is n here? N is 3. So nx power n minus 1, which is 3x power 3 minus 1. How much? 3x square. So d by dx of x cube is 3x square. Now try d by dx of x power 5. What are you getting? Pause the video and check it. Did you solve? The answer will be 5x power 4. So you can do any x power n form like this. Let's take the third equation. D by dx of some constant k into f of x. There is a constant multiplied with a function. Let's say some 2x square. Let's say some 3x power 5, something like that. A constant into function of x. Then what do we write? Simply bring the constant outside. K into d by dx of f of x. That's all. Simple. Let's solve a question. Taking this 3x power 5, d by dx of 3x power 5. So the constant bringing outside, so 3 outside, d by dx of x power 5. And we know it is an x power n form. So inside the bracket, d by dx of x power 5 is 5 into x power 4. So totally the answer is 15x power 4. This is d by dx of 3x power 5. So this is another method, another formula. Next, let's take few more. One important thing, d by dx of x. We are differentiating x with respect to x. Then the answer is 1. Simple. And why is it like this? Let's find out. D by dx of x can be written as d by dx of x power 1. Right? X can be written as x power 1. And it is in the form of x power n. Then what is the equation? Nx power n minus 1. Here n is 1. So answer is 1 into x power 1 minus 1. It becomes 1 into x power 1 minus 1 is x power 0, which is 1. That's why d by dx of x is 1. So this is another important formula. Going to next one. Now let's check a power, d by dx of some a power x. Okay, something power x. Now what is the equation? Here the answer is a power x into log x. Log x, and the base is e here, which we can also write as a power x into ln x. ln indicates natural logarithm, where e is the base, so it is natural logarithm. So ax ln x or ax log x to the base e. Let's see the next equation. So these are all from trigonometric functions. Sorry, these are all from algebraic functions. Okay, there is one more. If there is an exponential function, Remember this carefully. If y is equal to e power x, then finding dy by dx, which is d by dx of e power x. What the answer? It is e power x again. So differentiating e power x will give you the same result again. So e power x on differentiation is same, it is not changing. Okay, next, logarithms and exponential we will learn in a different concept. So these are some algebraic equations. Now let us see some trigonometric functions. Let us say y is equal to sin x, then what is the differentiation? Let us find out. D by dx of sin x is nothing but cos x. Similarly, d by dx of cos x gives you minus sin x. Then d by dx of tan x, result is secant square x. Right, so these are some important equations. Similarly, d by dx of cos x is minus cosecant square x. These are some important equations to remember. So I am displaying all the trigonometric equations here. Just you can pause and note down. Similarly, I'll show you some algebraic equations also. You can just note down by pausing the video. Right? Okay, suppose if there is an addition of 2 or 3 functions, then what to do? Let us assume f of x and g of x. There are 2 functions of x and y is equal to f of x plus g of x. F and g are 2 functions. Directly I am writing f and g. F and g are functions. F dash and g dash are their differentiation. Okay, we also call it as derivative. So f dash is derivative of f, g dash is derivative of g. So y equal to f of g, to f plus g, 2 different functions. Then what is dy by dx? This is d by dx of f plus d by dx of g. We can also write it as f dash plus g dash. Want example? Let us see. Suppose y is equal to x plus sin x. Then dy by dx is d by dx of x plus d by dx of sin x. And d by dx of x, you know already, it is 1 plus d by dx of sin x is cos x. So this is the answer for dy by dx. Simple. So like this, whenever there is addition, for subtraction also we do the same thing, right? So this is what we do when there is an addition of 2 functions. Now what if there is multiplication of functions? Okay, let us see. Let us assume there are 2 functions f and g. Again we want f is equal to 2 functions f of x into g of x. Then what is dy by dx? Equation is very simple. Dy by dx is, let's write here itself, dy by dx is f into g dash plus g into f dash. You know, f dash means differentiation, or you can also write like this: f into d by dx of g of x plus g into d by dx of f of x. Means keeping one function as it is, differentiating the other function, plus now keeping the other function as it is, plus differentiating the first function, like this. Let's do with an example. Let us say y equal to x cos x. Then the differentiation dy by dx is first keeping x as it is, differentiating cos x. So x into d by dx of cos x plus, now reverse, keeping cos x as it is and differentiating x. So first of all, x into d by dx of cos x is minus sin x plus cos x into d by dx of x is, sorry, here d by dx of x is 1. So totally answer is minus x sin x plus cos x. So this is the differentiation of x cos x. Correct? So this is another method when there is multiplication of two functions. Let us try one more. Suppose there is a function given to you, y is equal to x square into e power x. Okay, we already did e power x formula. So now dy by dx is leaving x square as it is, differentiating e power x, plus leaving e power x like that, differentiating x square. Next step, x square into d by dx of e power x is e power x only, plus e power x into d by dx of x square is 2x. So totally answer is x square e power x plus 2x e power x, or you can also write e power x common, x square plus 2x. This is the answer. Is it clear? Right? That's all. So it is very simple when there is multiplication of two functions. So still we have to discuss, what if there is division of two functions and also some other applications of the differentiation. Before that, let us practice few more questions. Okay. Assume that y is equal to x square sin x. Then dy by dx is equal to, how do we write? Dy by dx is d by dx of this entire thing. Here we have multiplication of two functions, one is x square, other is sin x. So using that method, what we say, d x square leave it as it is into d by dx of sin x, plus leaving sin x as it is now, d by dx of x square. Now what is the result? X square into d by dx of sin x, cos x, plus sin x as it is into d by dx of x square is 2x. So total answer is x square cos x plus 2x sin x. That's all. Okay, try this one. Let us say there is a function y is equal to 2t plus 1, where t is a variable. Now find out dy by dx. Pause the video and find the answer, and then come back to check the answer. Pause, try. Right? Got the answer? Now let us check. Here the answer is 0. Have you got 0? Answer should be 0. Why? Observe here, y is a function of variable t, which means y is independent of x. From x point of view, y is a constant. It is not depending on x. So dy by dx is nothing but dy by dx of a constant, which is 0. Okay, if I do differentiation of y with respect to t, then I will get d by dt of 2t plus d by dt of 1, which is 2 plus 0, which is 2 answer. When I differentiated with respect to t. But when I ask differentiating with respect to x, answer is 0, because the function belongs to t, not x. Right? Okay. One more equation is there you have to remember, that is d by dx of log x. This is 1 by x. Remember this. If there is a logarithmic function with base e, then it is 1 by x. Okay, let's try few more questions. There is a function given to you like this: y is equal to x square plus x sin x. Then what do we do? Two functions are there, addition, and again in the second term there are two functions multiplying with each other again. So simply let us write like this: dy by dx is d by dx of x square plus d by dx of x sin x. First dividing the addition, then d by dx of x square plus, now use multiplication method, leaving x as it is, d by dx of sin x plus leaving sin x as it is, d by dx of x. So becomes 2x plus cos x into x plus sin x into d by dx of x is 1. So final answer is 2x plus x cos x plus sin x. So if you want to do, no sir, I will do directly like this. I will take x common and I will write it as x plus sin x. Again you can use UV method, again multiplication method, again this is same. Okay, that's all. So next, now coming to still we have division method, which means two functions dividing where y is f of x by g of x, how to do, and also some more applications we will learn in part 2. Okay, so revise this properly before going to part 2. All the best. Jai Hind.